Okay, so welcome to, depending your various routes, either a half a module or a full module. We're combining the second half of ESC 10084, which is Geology and Society, with the standalone module ESC 20037, which is an optional module for both geography and environmental students. So we're having a look at the whole range of perspectives of how geology and geoscience interrelates with society in this module from a whole range of different perspectives, but probably more of a geologically biased perspective than a lot of these issues to do with society have been dealt with before. It has to be said that at the minute, geology has a bit of a bad name out there. We tend to dig things up. We're largely responsible ultimately for polluting the Earth's atmosphere, driving global climate change, etc., etc. So this is a geologist's version of these arguments. In some feedback forms in the past, it has been described as good but a bit ranty. We'll have various rants along the way, but it will be hopefully some interesting perspectives on this very intertwined relationship between geology and society. And I've got a saying that it's only geologists that can save the planet now. That if you actually want to be serious about reversing global climate change, pretty much most of the solutions are geological, and we're going to need geologists to do it. That the techniques for carbon sequestration are pretty much the reverse of what we do in the oil and gas industry. We've got to find reservoirs that are capable of storing gas on geological timescales. If you want to have nuclear power, which is carbon neutral, you need to be able to store the radioactive waste safely. Pretty much all of those solutions are geological. If you want cheap or relatively cheap carbon neutral energy coming from the Earth, then one of the main solutions to that is geothermal. Our modern way of life still requires a lot of mineral resources. Sand and gravel extraction and limestone extraction for making cement are actually probably bigger environmental challenges than a lot of other things that we have to consider. But hardly anybody actually thinks about, how do you make glass? You melt sand. What's the main constituent in your toothpaste? Limestone. Pretty much, if you haven't grown it, a geologist has found it. From iron ore for steel, sand for glass, limestone for cement, the rare earth elements in your mobile phones, the aluminium for wind turbines. It's geologists that have found it, and if we want to have a sustainable planet going forwards, then we need to have things such as sustainable mining, sustainable energy resources, and so forth. And as I said, most of the solutions to the 21st century are ultimately geological. So, bit of background to what we are aiming to do. The course aims come both from the Geological Society of London accreditation document, which specifies the nature of geology courses and geoscience degrees, to help develop awareness of the essential contributions of geoscience to the economic, environmental and cultural needs of society. And we're also going to be reflecting on the various aspects of geoscience that relate to the UN Sustainable Development Goals, the SDGs. Our objectives are a whole range of things to should be able by the end of this course to demonstrate and critically evaluate and communicate effectively and apply awareness and informed concern of a whole series of things. So earth science challenges in the exploration for and the development and exploitation of earth resources, geological aspects of human impacts on the environment, geohazards and their impacts on human societies, earth science perspectives on sustainability and social awareness. There's something in mining now called a social license to operate. Previously, you've had to have a license to operate, if you like, a permission from the government to put a mine in. And that's been historically based on things like environmental concerns. But a social license to operate is permission from the general public. If you want to start a mine or a quarry anywhere in this country, you are going to encounter a huge amount of public opposition. And you've got to bring society along with you to persuade them of the needs of society ultimately for that resource are greater than the disruption that you're going to cause when you're exploiting that resource. Also looking at things like environmental challenges in natural diversity, demand and scarcity, demand for and consequences of resource utilisation, energy and material production and use, including alternatives. Approaches to and limitations of environmental management systems, role of institutions in regulation and management of the environment, environmental policy formulation, legislation, decision making. Not a lot. I said the topic of geoscience and society is a huge one, and we're just going to scratch the surface of it and start some of the debates going. As I mentioned, there are two pathways. So if you are doing this as a 15 credit option from geography, environmental science, environmental sustainability, then you're doing ESC 20037. It's 15 credits, so the totals in this, your part, should add up to 100% of the module. There's a 2-hour written exam, which is 50% of the module. I'll get you to do a short presentation on a particular resource. That will be worth 15% of the module. And towards the end of the module, we will have a 1-day field day looking at various aspects of geoconservation, public understanding of science, science communication, indeed environmental communication. And there are a couple of pieces of work associated with that, which will give you the remaining 35% of the module. If you're doing it as part of 10,084, sorry, that should be 84, So it's half of a 30 credit module, so these totals should add up to 50% of the module. So half of the 2-hour written exam is 25%. Your resources presentation is worth 5%, and the geoconservation and public understanding of science poster is 20% of the module. But pretty much we'll be doing exactly the same things for both streams. There's just a slight variation in the weighting, partly because obviously the geologists amongst you would have a slight broader understanding of some of the items behind that, so the poster's slightly down weighted if you haven't got the background as a geologist. In terms of deadlines, the resource presentations will be in week 6 and week 7. What we will do is we'll do this by random allocation, so everybody will get 2 weeks' notice of doing their presentation, what their particular resource will be the topic of their presentation. So you'll be randomly allocated to either week 6 or week 7, and you'll know in either week 4 or week 5 what your topic is. And we will have a final deadline for the field day documentation, which will be the Wednesday in the middle of week 12. Which is in May sometime, I think. As I mentioned, we do have a field day. That will be Saturday the 21st of March. We'll go over to East Staffordshire, up into the Staffordshire Peak. We'll spend the morning in a former quarry, where we'll be looking at aspects of geoconservation and geodiversity, and then in the afternoon we'll have a look at part of a geotrail and look at how do you develop interpretation materials for the general public to understand your science. Yes?
You've got a petrology field trip that day as well?
I shall sort that one out. No, you haven't, is the answer. And the course text for this module is Murray Gray's book on geodiversity, valuing and conserving abiotic nature. It's available as an e-book from the library, so everybody can have access to it, and it's really quite useful if you've not got a background in geology. It does cover a lot of geological issues in a very simple, easy to understand language. So if you do need to look at some of the issues behind some of the items that we'll cover on this course, it is very easy to read for non-specialists. For those of you who are not used to me lecturing, generally I expect you to take your own notes. My slides will largely be just pictures, and I shall basically talk about those pictures. If you don't understand something, do stop me and I'll try to explain what's going on. As I said, there's a lot of, I think, interesting issues that we'll cover over the next few weeks. I'm going to try. I may not succeed. Stuff does tend to get in the way, But my initial plan is to try and finish the taught part of this module this side of Easter. Okay, so I'm going to try and put everything into the 9 weeks that we've got before Easter. We've got this 3-hour slot on Tuesday afternoons. So a typical afternoon will have probably 2 lecture sessions, and then maybe a small practical or a small something else in the 3rd hour. So, for example, today we've got the introduction to this module. What I'm doing now will give you a session on the introduction to geoconservation, and then we'll have just a little exercise looking at how we can analyse mineral water bottles and to say something about the geology of where a spring water comes from, simply from reading the analyses on the back of the bottle. Next week we'll continue the sort of the geoconservation theme and have a look at geoethics, the ethical issues behind what we're doing, and also the relationship to the United Nations Sustainable Development Goals. The red titles in here are the geological hazards. So subsidence, landslides, earthquakes and tsunami. The blue topics are energy resources, so coal, carbon capture and storage, geothermal, radioactive waste from the nuclear industry, and hydrocarbons, both conventional and fracking. And we'll finish off with geology and health and geoengineering, which is how to hack the climate. And you can see that we'll also have the mineral resources talks in weeks 6 and 7. So just some of the topics that we're looking at. Obviously starting off with the introduction, which is now. Then, starting after our short break, look at items to do with geodiversity and geoconservation. You're probably really quite familiar with the term biodiversity. You know, people tend to bang on about diversity at length. They tend not to talk about the abiotic companion geodiversity, the range of geology of this planet, and it's quite easy to persuade people to save the otter or to save the whale, but it's a lot harder to get them to save the peridotite or save the granite. We'll also, said in this course, have a look about how we try and communicate our subject with the general public, with things like geological trails, signboards at geological outcrops and exposures. We'll have a look at some of the issues of how we put the conservation of geological sites into the regulatory framework, into planning laws, into international treaties, and so forth. Things like World Heritage Sites. Have a look at geoethics and how we can use geology and geoscience for a more sustainable planet, and how it all integrates into the UN SDGs. Geohazards, looking at things such as landslides and subsidence. The biggest source of insurance claims, on house insurance claims in this country, is ground subsidence. It's not that they get knocked down by earthquakes or volcanic eruptions. It's because you have clays in the ground that swell in the winter when they get wet and shrink in the summer when they get dry. If you've got a tree growing next to your house, the tree roots help that shrinkage and swelling, and it knocks your wall down. But again, ultimately it's related to the geology. On the bigger scale, obviously, we've got the earthquakes and tsunamis issues. You know, the Boxing Day tsunami of 2004 in Indonesia killed almost 250,000 people. But it was forecast. Not predicted, but there were seismologists who actually went out to this part of Indonesia and were trying to warn the authorities that this area was at risk from tsunamis, and nobody did anything about it. And 250,000 people died. So again, it's this interrelationship between geological knowledge and public understanding of science and regulation by politicians. It's all intimately linked. Resources and society, as I've mentioned previously, our modern world has a huge demand for metal resources, for energy resources, and things have not only got to be sustainable, but they've also got to be affordable for modern living. Everybody wants an iPhone or a smartphone. Everybody wants a means of transport. Everybody wants heating and lighting in their house. Yeah, that all comes with a cost to the environment. We'll have a look at some of the sources of energy for a lower carbon, carbon neutral, carbon negative world. This is a coal bed methane rig that was put on the far side of campus, and enhanced coal bed methane extraction can actually be carbon negative. You can actually store twice as much CO2 as you bring methane out of the ground. So we'll have a look at some of the ways that we may be able to use coal still in a sustainable fashion. We'll have a look at CO2 sequestration, taking the CO2 that we produce from power plants and storing it safely underground for geological timescales. And we'll have a look at some of the other solutions, such as geothermal. And everybody is quite familiar with the geothermal power stations in Iceland, but less familiar with some of the geothermal initiatives that are currently going on in the United Kingdom. Again, if we want to move to a low carbon or zero carbon world by whenever we want to get there, sooner rather than later, then things like geothermal have got to be part of the sustainable energy mix. If you're going to use nuclear power, and if you look at the energy production and the CO2 production as a consequence of that across Europe, you see that France has a very low CO2 output because they get a large amount of their energy from nuclear power. But nuclear power comes with its own problems. You generate radioactive waste, which you have got to be able to store safely for geological timescales. Yeah? Timescales on which you're talking hundreds of thousands of years to millennia. We've had ice ages on those kind of timescales. What happens if we have another ice age and the ice advances over the area where we've put our nuclear waste repository? How do you put a marker, a warning sign, to warn future generations that may not speak any language we currently speak from saying, don't dig here, it's dangerous? Or dig here with caution and you've got a potential power supply if you can reuse it. So some of the issues associated with radioactive waste. And then oil and gas. Now, whilst we are moving away from oil and gas at the minute, particularly oil, gas is still going to be a very significant part of our energy mix, at least for the next 20, 30 years. Whilst you can start charging your car electrically, most houses in this country still have a gas boiler for heating. And a lot of hydrocarbons are actually used for heat rather than light and power. And whilst renewables are still only a very small fraction of our energy mix at the minute. So what are the considerations to do with oil and gas going forwards? Geology and health. There are times when geology is trying to kill you. We've got things like this, which is asbestos. You've got things like heavy metal poisoning, things like cadmium and lead. You've got some particular elements which you actually need in small amounts, like fluorine for your teeth and your bones, but too much will kill you. So we'll have a look at geology and health, and then, as I said, we'll finish up looking at what's known as geoengineering. How, if we say, and you actually look at what's happening in the real world with Trump in the White House, with the Chinese not exactly cutting back very quickly on coal-fired power stations, producing sort of several hundred new airports in the next 5 years. I really can't see, I'll be glad if I'm wrong, but I really can't see our planet meeting those Kyoto targets of keeping temperature rises to under 2 degrees from background 1960 levels. If we can't do that, then there's a number of processes that start to generate a climate runaway. That if you start melting the permafrost, you release methane into the atmosphere, which is a much worse greenhouse gas than carbon dioxide is, and that will make matters even worse. That will then release methane hydrates from the oceans, which will make matters even worse still. It may be that to turn round this climate supertanker, just disposing of your plastic bottle sensibly is not going to be enough. We may have to make some very large interventions on our well, largely on the CO2 which is currently in the Earth's atmosphere. And as we mentioned, a lot of the solutions are in one way or another geological. So we'll have a look at some of those. There's not a huge amount of practical work, largely because after I've been banging on for 2 hours, everybody's completely bored and fed up, including me. So relatively short, practically type things, none of which are particularly assessed. Well, we'll come on to the bits that are assessed as we go through it. So we're finishing up today with, as I said, having a look at how we can tell geology from spring water. Next week, we're just going to have a look at just a flavour of some of the issues to do with geoscience and society. What I plan to do in week 3 is, well, on our field day, whenever it turns out to be, on our field day, one of the assessed exercises is a form where you're going to analyse the geoconservation status of a particular site. So it's called site condition monitoring, and it's something that we do routinely for geological sites. Because it's assessed in the quarry, what I'm going to do, hopefully in week 3, is just take you down to the Clockhouse Drive and show you how to do it on a geological site. So you've got an idea of, when you do the assessed exercise, what it is you're doing and how to fill the form in. Yep. If it is pissing down with rain in week 3, we'll do it in week 5. Okay? But do come prepared in a fortnight's time just to go out across the road. So we're not going far. You don't need a hard hat or a geological hammer. Just probably need something warm and maybe lightly waterproof. Week 4, I give my most dangerous lecture of the year, which is a talk on how to give a talk. And that is to give you some hints and tips on how to go about producing your presentation for weeks 5 and 6, so 6 and 7. So week 5 is our reserve day in case it's raining in week 3. Week 8 should be field course preparation, and week 9 should be if we need to do any follow-up to the field trip, which should be at the end of week 8. Okay, so as I mentioned, what we're going to be doing at the end of next week is just having a look at some issues to do with geoscience and society. And this is where I want you to do just a little bit of work between now and then. I'd like you to just go on the interweb and find an issue relating to geoscience and society that happened last year. Could be an earthquake, could be a volcano, could be a discovery of an oil field, could be whatever. As long as it is geoscience and society. Because we've got people doing 2 different modules, they're on separate parts of the KLE. Which is a nightmare for me because I've got to duplicate everything. So if something's missing on the KLE, do let me know, because I might have loaded it on one side and not repeated it on the other. But in order to try and get round that, for this particular exercise, I've set up a Google Classroom, which everybody should be able to access. So if you just ultimately go into a web browser, you must be signed on with your Kiel, signed into Google with your Kiel email. But if you are signed into Google with your Kiel email, then classroom.google.com, and then in the top right it should have a thing to join a class, and the class you want to join is QNDS2VU, and it does work because somebody's been super keen and already done it. So all I want for this time next week is a title for your issue, a link to the web page, and just one sentence describing what the issue is. Now, the problem with having to use Google Classroom instead of the KLE is that Google Classroom doesn't come with discussion boards. So I have to fake a discussion board using an assignment. So although you'll see it's an assignment, it's not a marked assignment, and you don't actually submit anything to the assignment. But there is a comment area of that assignment. So look for the comments of the assignment, and you should just be able to add a comment on to the pre-existing comments, because there's already two. There's one from me and one from the first person to has actually had a look through the source material first and found it. So you open the assignment, you add your title, your link and your sentence as a comment, and then you can mark the assignment as done, although you actually haven't done the assignment, if that makes sense. It should be obvious, because as I said, somebody's managed to do it without the explanation. Only a few rules. I've forgotten to change that slide. So you must add it to the discussion on the Google Classroom. You cannot choose a topic that somebody has already chosen, so look to see through the comments so you don't duplicate anything. The idea is just to get a flavour of all of the different issues to do with geology and society that are out there. Different minerals count as a different issue, different energy sources count as different topics, different earthquakes, different tsunamis, different volcanic eruptions all count as different topics. The only thing is it must be geoscience, so storms, floods don't count, wind turbines don't count, anything biological doesn't count. Any questions? Relatively straightforward, one would hope. Possible sources include obviously news, science, environmental websites. If you're going to use newspaper sites, just so that if I need to put the web page up, could you make them open access? So things like The Guardian, I hesitate to say the Mail Online, but something that we can have a look at if needed. I mean, I do have a Times subscription, so if it's behind the Times or FT paywall, I can probably get there. But trade websites, There's a site called mineweb.com that gives a lot of mining news. There are various science blogs and aggregators, and then there's the search engine news. And there's a whole host of sites relating to volcanoes and earthquakes, and there's plenty of potential sources out there. And the deadline for submitting your comment is, the start of the session next week, so 2 p.m. next Tuesday.